Freeze! Stop right there. What do you think you're doing?
Oh, I'm just Professor.
Kepler's law.
Pen on your back.
I wasn't doing nothing.
You have the right to remain silent. And you can...
What are you doing to my son?
Sir, stand back. This is police business. Mind your own business.
I'm standing on my property. I'm allowed to be here.
Sir, you have to back away. This has nothing to do with you.
Don't worry, son. I'm right here for
Sir,
you.
be quiet. Back away, now.
Who wants to learn some calculus? Hey, I like what you're doing here, Dre, but none of that Kepler stuff, right? I want people thinking about calculus, not Kepler. Alright.
Hey guys, I'm Professor Dr. Dre, and today we're going to learn all about Kepler. Kepler was a mathematics teacher during the scientific revolution. He made many inventions such as different types of telescopes, and he lived in an era where there was no clear distinction between astronomy and physics. However, Kepler's studies brought a lot of controversy because he accurately created a connection between physics and astronomy. So Kepler's first law states that a planet orbiting around a star will always orbit in an elliptical pattern. Oh yeah, and the police don't like Kepler. So Kepler's first law stated that that a planet orbiting around a star will always orbit in an elliptical shape, with the star at one of the foci of the ellipse. So that looks like this. In an elliptical orbit, there are two axes. There is the major axis and the minor axis. The minor axis, or the semi-minor axis, which is half of the minor axis, is denoted by B, and is the distance between this point on the ellipse and the center of the ellipse. The semi-major axis, on the other hand, is denoted by A. The eccentricity of an ellipse is, in essence, exactly how elliptical the ellipse is. The extreme case of eccentricity is an eccentricity of 1, where it is so eccentric that it is no longer an ellipse. The eccentricity can be calculated by E equals the square root of 1 minus b squared over a squared. When the eccentricity is 1, that means that b has to be equal to 0. So these two will overlap with the center, and it'll end up being a parabola, and it'll open out like that. The other extreme case is when the eccentricity is equal to 0. That happens when b and a are equal. So these foci overlap with the center, and you have an orbit that looks like this. Let's pretend that's a circle. So, thank you, and that is Kepler's first law.
Are any fun facts about Kepler?
Yes. Kepler was one of the first people to say that the sun is in the center of the solar system, rather than the Earth is in the center of the solar system. And he was a teacher of astronomy and physics in Europe. Yo, get off my little brother!
What's going on here?
I fell.
Is that right?
That's what he said, right?
Are you sure this has nothing to do with Kepler's law?
Nope.
Yeah, right. Get on the ground.
Yo, thanks for bailing me out, man.
No problem. What'd you even do this time?
I was literally just standing there.
For real?
Yeah.
Damn, that's the most gangster thing I've heard all week.
Oh, Jerry Heller.
Look, Jerry, I'm easy.
I heard your stuff. It's pretty good right here.
Pretty good? Only pretty good?
Okay, no, my bad, man. Not just pretty good. It's great. It's phenomenal.
Yeah, that's what I thought.
You guys need an agent to take you into the big leagues. I'm that guy.
Alright, deal.
Action.
What are you guys doing here? We're gonna do nothing. Yeah, right. Get on the ground.
No way!
Get on the ground! Interlock your fingers behind your back.
Yo, what are you doing? These are my artists. They work here. You can't do this to them.
Your artists look like gang members.
You can't judge people by the way they look. Come on, guys, get up, get up.
Stay on the ground. You get up when I tell you to get up.
This is ridiculous. Boys, let's go.
Wait. Yo, what up, Tyree?
What up, Dre? Take me on tour with you.
Yeah, I'll take you on the next tour. I think we're going to Miami next time.
I can't wait to see you profess Kepler's law in Miami.
Alright, bro. I'll see you when I get back.
Committing any obscene, independent, or immoral acts in a public place. Note also that performance of the lecture
Kepler's law.
will not be permitted. Refusal to abide by all Detroit City ordinances will result in immediate arrest and forfeiture.
Can we go now? We got a lesson to teach.
Dang, that stuff was dope.
Alright, hold up everybody. You know what the police tried to tell us backstage? The police tried to tell us what we can't teach. The police tried to tell us what we can't profess. But this is the MWA. We teach what we want to teach. We profess what we want to profess. So everybody, put your pencils high in the sky. Hey, Dre.
What up, Q?
I got something to say.
We're going to learn about Kepler's second planetary law. So Kepler's second law states that planets sweep out equal areas in equal times. So all planets have eccentric or elliptical orbits around their star. And in our case, our star is obviously the sun. And here would be the Earth. So we have an elliptical orbit around the sun. And let's take two instances, for example. One where we move from this point to this point, and another where we move from this point to this point. And in both cases, the time intervals are equal. And these shaded portions represent the area the Earth sweeps out in these intervals. And when the Earth is closer to the sun, the gravitational force is stronger, and so it moves faster across this area compared to this area when it moves slower because it's farther away and a weaker gravitational force. But in both cases, since the time intervals are equal, the areas, both these areas are also equal. And so, where's the eraser? Where's the eraser?
Oh, I got you.
So, we obviously know that there's a gravitational force between the sun and the Earth, which we'll write as Fg, but there's also a position vector parallel to the gravitational force vector that we'll call r. So this represents the position of the Earth as it goes around in its orbit. And so we know that torque is equal to the position vector r cross the gravitational force, which would be Fg in this case. But we can also represent the cross product by this formula: the magnitude of r times the magnitude of the force of gravity times sine theta. And in this case, theta is the angle between r and Fg, but since, as we stated before, both of them are parallel, theta would be 0 in this case. 0 degrees, which means sine would be 0, which means this whole thing cancels out, which means torque is 0 as the planet moves around its orbit. So everywhere torque is 0. Now additionally, we know that torque can be represented as dl dt, or a change in angular momentum. And here L represents angular momentum. Right? So as we stated before, torque in this case would be 0, which means that dl dt is also 0, and this means that L everywhere across the orbit of a planet would be constant. And we also know that angular momentum is equal to the position vector r cross translational momentum p, and we know that p is equal to mass times velocity, but in this case m would be mp because it's the mass of our planet. And so we know that we can plug in mv for p in this instance, and we get r cross mp times v. And here we can just bring the mp out. So we get mp times r cross v, right? But we can make a substitution for r in this case. So here's the sun, and here's the earth, and this is the area they sweep out. So we know the position vector r would be this line right here, and then there's also the length it travels, which would be in this case dr, right? And we know that distance is equal to velocity times time, but in this case, since it's dr, it would be v times dt. And we can represent the area by dA over here. So we know since there would be a triangle between all these points, we can say dA equals 1/2 r cross dr. And then we can write this as 1/2. When we substitute in here, we see that okay, so when we see r equals v dt, we just write 1/2 and r cross v dt. I forgot to put there. But then we see here r times v. here also, which equals angular momentum. So if we divide by mp on both sides, we get r cross v equal to angular momentum over the mass of the planet, mp. So we can just substitute that in right here. So we get 1/2 L over mp dt. And this is all equal to dA, right? But then we can divide by dt on both sides, and dt will cancel out here, and we get dA dt equal to 1/2 angular momentum divided by the mass of the planet. And the mass of the planet is always constant, and as we proved before, since the torque is 0 at all times around the orbit, that means dl dt, which is also equivalent to the torque, is 0, which means that the angular momentum L is constant throughout. So we have a constant over a constant times 1/2, which is a constant. So all this would be constant. Thereby proving Kepler's second Planetary law that time speed by equal areas in equal time, since dA dt is always constant throughout. We're done. How long is it?
Your lessons. They have glamorized the teachings of Kepler, which the police don't like. What do you have to say for yourselves?
We gave the people some knowledge.
Yeah, you guys got a snapshot of what the people really want to learn.
I walk in the classroom every morning, and what do I see? I see calculators from Colombia and smart boards from Russia.
And none of us got passports.
So cute. What does a guy do when he starts making some real money?
Buy more pencils and paper.
Word.
So, are you going to be more careful about what you teach?
Well, as far as I'm concerned, we're just exercising our First Amendment rights.
And the government taught us that.
Kepler's law.
Dope, man. Yeah, can't wait to teach it at our next concert. We're gonna profess so hard. Yeah, it's gonna be dope. Alright,
it's my mom. All good.
What's up, Malls?
what happened?
My mom just called. It's my brother, Tyreek, my baby bro. He got in a fight. He's dead.
That's alright, sorry.
Brothers for life.
But none of this would have happened if I brought him on tour, Mom. This is all my fault.
Don't do this to yourself. You did everything you can for Tyree.
Good to see you, Cute.
What's up, Jerry?
Now, you've been pretty eager to sign with Eric's company.
You mean your company?
Not my company. I work for you, Cute. Now, I need you to sign this contract right here.
Alright, cool. I'll take these to my lawyers.
Don't take it to them. They only know how to complicate things.
You know I don't know what all this legal stuff means, Jerry. None of us do.
You know everyone else has already signed it, right? You're the only one who hasn't. Now, there's this $75,000 right here.
Oh, nice.
It's yours after you sign it.
Well, what do you mean? That's my money anyways. I wrote a lot of hit lessons for...
Kepler's law.
How do you think this works? Do you think this is all free? The calculators, the pencils, the rulers, the protractors? How do you think this all gets paid for?
Bye, Jerry. I'm out.
Are you sure you want to leave?
Yeah, I'm fed up with this stuff.
You do realize that the solo industry is a lot harder than the group industry.
Yeah, I'd rather teach by myself than get backstabbed by these guys. I got a bunch of dope lessons. When can I get my money?
Alright, so if your first lesson on Kepler's law is dope, I'll give you the money.
Alright, we got a deal. Don't worry, it will be.
Hello. It's Ice Cubed here. Ice Cubed. And today, we are learning Kepler's third law. What is Kepler's third law, you may ask? It is the period of a planet, like the time it takes to go around the sun, squared, is directly proportional to the semi-major axis cubed. Okay. And yeah, we're gonna prove that. Alright, so what we already know is that dA dt is equal to h over 2, as we proved in the previous proof. So what can we do with this? Well, we could rearrange it so you get dA is equal to h over 2 dt. H over 2 dt. For that. Now what should we do with this? We should integrate. So now we'll integrate dA, and h over 2 is a constant, so we can take that out. Dt, and the bounds would be from 0 to big T. So this turns into area equals h over 2 Alright, just ignore that. Just ignore that. Alright, so h over 2 big T. Alright. So now, alright, so we already know what the area of an ellipse is. That's easy. Area of an ellipse is equal to pi AB. So now we can set that equal to h over 2 big T. Oh yeah, and A is the major, semi-major axis, and B is the semi-minor axis. Now we can set h over 2 big T. And now we will solve for T. So T is equal to 2AB over 2AB pi over h. Alright, this, we're going to come back to this formula. Just going to put it to the side. Maybe just put it away for now. Alright, let's erase this. Alright, so now another formula that we already know. That's a given. Is ED is equal to h squared over gm. There's another proof for this, but that's for another time. Okay, and we also know, now you know that's there, and this ED is also equal to b squared over a, which is another proof, not for today, but just know that's true. ED is equal to b squared over a. Oh yeah. And E is equal to the eccentricity. And D is the directrix. Okay. So, what can we do with this now? I'll tell you what we can do. We can rearrange this. So, we could rearrange this for solve for h squared. So h squared is equal to g m b squared over a. Here, I'm just gonna box this pile over there. Sweet. Alright. Yeah, so now you know what we could do? We could go back to this formula. We could go back to this thing that we solved for. And we can, combine these. So you know what we get? We would get T equals T squared equals 4 pi squared a cubed b squared over g m b squared. Oh yeah, and then the b squareds cancel out. So then we're left with this. T squared equals 4 pi squared a cubed over gm. So now we're done. We're done. See, look at this formula. And let's just rewrite it so it's a little more clear. Get T equals 4 pi squared over gm. And these are all constants, by the way. I'm not sure if I mentioned this earlier, but g is the gravitational constant and m is the mass of the sun. So we get T equals 4 pi squared over gm. Oh, a cubed. Now, does that look familiar? It does. Oh, it's T is the period of oh yeah, I should have told you this earlier, but big T is the time it takes for a planet to go around the sun, which is equal to P. So T squared is on one side, a cubed is on the other side. Directly proportional. So, what can we do with this, you may ask? Alright, well, what can we do with this, you may ask? Alright, so, what can we do? We can, alright, say I want to go to Mars, and I want to find out how long a year is there. So you know what we do? We'll just go like this. P, we'll just turn this into an equation and just like solve as if it's an equation. So the semi-major axis for Mars, A for Mars, is equal to 1.524 a I mean, I forgot what units they. Oh, 1 AU. The semi-major axis for Earth is 1 AU. The one for Mars is 1.524 AU. AU. Kidding. Alright, so we plug this in for A. And then we get, you know what we get? When we solve for P, we get just calculate it, do some mental math. 1.88 Earth years. Earth years. So, if you want don't know where to travel in Mars, probably you want to go during summer, you go when it's summer in 1.88 Earth years. And, well, that's the end of my lesson. Hope you learned a lot.
I'm just telling you what you told me. If Kepler's law blew up, you pay me with the follow-up. Now, is that not what you said?
What I said was more complicated than that, Cubed.
Come on, Brian. I got baby on the way. And I just bought a house off the strength of your words.
Calm down, Cube.
Been doing the work. I gave you the product. Now, where's my money, Brian? If a man does a job, he's supposed to get paid. Now, you're making it look like I'm begging for something that's technically mine.
I'm not trying to be difficult.
But you can't help me.
My hands are tied.
You should have kept your word, Brian.
Jesus Christ! Stop it!
You think I care about these lessons?
Stop! I'll give you the money.
Take it out what you own.
Stop! Calm down, Q. Stop!
What up, Jay?
Yo, what's good?
Do you see your ruthless paperwork?
Nah, what's good? What's good with this?
I don't think you're getting a fair share. Join me at death row, and then I'll make sure that you get a fair share.
How would I even get out of this contract with ruthless stuff?
Don't worry about it. I'll take care of it.
All right.
Yo, what up, Suge?
Yo, come down to the studio. We need to talk.
What for?
Just come down.
Alright, I'll be there.
What's going on, man?
What is this?
You're gonna sign these release ones for Dr. J and DLC.
You must be stupider than I thought if you think I'm gonna sign that.
Do you know I'm studying? This is calculus.
Man, forget this.
Keep talking. We'll be messing around to get smoked.
Man, get out of my way.
You good? You good?
Yo, what up, E?
Hey, yo, Dre. Yeah. I was just thinking, I didn't like the way things ended between me, you, and Cube. You know, I want to get MWA back together. What you think?
Yeah, sure, let's do it. Alright, peace.
What up, Dre?
I'm done. I'm out.
You really gonna leave all this money behind? If you leave, death row stays death row. You ain't taking no teachers or lessons.
I'm starting off on my own, Suge. Nobody to answer to but myself.
What are you even gonna call it?
After math.